Hi everyone! Today we're going to be looking at the quadratic formula, so what exactly that is, where we can apply it, and what it helps us find. But before we do that, we're going to take a few steps back and remind ourselves of what we've been doing in class these past few days, because we're really going to build off that today. So here we have what we've been calling a quadratic equation, which is in the form of ax squared plus bx plus c equals 0, where a, b, and c are constants. And we've been solving these equations using factoring or other methods to get the roots of a function, which is where the function crosses the x-axis. So an example of how we've been doing this can be seen below. So here we have x squared minus 2x, and that should say minus 15 equals 0. And what we've been doing to solve these is first we've been looking at the factors of our c value, which in this case is negative 15. So the factors of 15 are 1, 3, 5, and 15. Then we've said, okay, which of these factor pairs can add up to negative 2? Because that's our b value. And in this case, that leads us to x plus 5 and x minus 3. We've done a ton of practice with this, and we're all pros here. And from then, we're able to conclude that x minus 5 and x equals 3 are our two solutions, our two roots of this function. So now let's take a look at another example. Here we've got a more complex quadratic equation, 6x squared plus 5x minus 4. So we do the same first step when we look at our factors of our c value, which is 4. We get 1, 2, and 4. But here, none of the factor pairs add up to 5, which is what we typically want to find. And so we're stuck. This is where our quadratic formula comes in. So what is the quadratic formula? When you have an equation, in a quadratic equation, the quadratic formula says that your roots, x, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This seems pretty complicated and definitely seems difficult to remember, but luckily we have a little trick to it. A great way to remember the quadratic formula is to sing the quadratic formula to the tune of Pop Goes the Weasel. So in this way, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Although this may seem silly, it's a really great way to remember the formula and to remember so that you can apply it to different equations. Now that we see what the quadratic formula is, let's head back down to example 2 and see if we can find a way to solve for those roots. So just to remind ourselves, we'll put our quadratic formula here. And let's get a fresh start on this problem. So we can see that x is going to be equal to, and negative b is our first step. So we look, and we'll do some labeling here just to make it more clear. Our b value is 5. Our a value is 6. And our c value is going to be negative 4. And you really don't want to forget that sign in front of there. That's going to make a big difference when you're solving these. So heading back down to plugging into our formula, we've got x equals negative 5 plus or minus the square root, and again b squared, so 5 squared, minus 4, and our a value is 6, and our c value is negative 4, all over 2 times 6, that same a value there. Simplifying this a little bit, we get that x equals negative 5 plus or minus the square root of 25 plus, and if you do this multiplication out, you can get 4 times 6 is 24, times 4 is going to give you 96. And that's going to be positive because we've got double negative in there. And that's over 12. Simplifying this further, we get x equals negative 5 plus or minus the square root of 121 over 12. And simplifying one more time, we can bring that down to x equals negative 5 plus or minus 11 over 12. Now is the point where we're going to break apart that plus or minus to find our two roots of the function. So dealing with the plus side of it, we've got x equals negative 5 plus 11 over 12. And with the negative, we've got x equals negative 5 minus 11 over 12. Solving each of these, we get x equals 6 over 12, which is equal to 1/2. And x equals negative 16 over 12, which is equivalent to negative 4/3. So the two roots to this function and the two solutions to your equation are going to be x equals 1/2 and x equals negative 4/3. And that's how you apply the quadratic formula. Let's try this with one more example here. Make sure we really got a good understanding of it. So if we move over to example 3, and one more time we'll copy in that quadratic formula, just make sure we follow it exactly. So here we've got 3x squared rather, plus 5x plus 1 equals 0. So plugging in, just like we did on the last one, we're left with x equals negative 5 plus or minus the square root of 5 squared minus 4, our a value is 3, and our c value is 1, all over 2 times 3. So we can go through and we can simplify this again, just like we did with the last one. And we get x equals negative 5 plus or minus the square root of 25 minus 12, all over 6. Simplifying some more, that leads us to get x equals negative 5 plus or minus the square root of 13, all over 6. Now 13 isn't a square number, and so that's going to lead us to get a complex answer, not whole numbers, not easy fractions to deal with. So you can just box that right there, and that can be your final answer. If you end up doing out the work for that though, you get that x is equal to about negative 23 hundredths and negative 1 and 43 hundredths. But again, just to reiterate, you can leave that as the fraction. Alright, and that's our final example there. So, today we've looked at the quadratic formula, how we can apply it, and we've seen it in a couple different examples. As you can see, it's a lot less scary than you might guess it is, and it lets us do a lot more in regards to manipulating those quadratic equations to find our roots. Thanks so much! Have a good day!